All right, good afternoon, everybody. This time for the serious question. Are you able to hear me clearly? Yeah. Yes, okay, thank you. At any point, if you're not able to, holler, raise your hands or something like that. Like I was telling Simon, I have about 20 minutes worth of slides, and for the rest of it, I'd like to make it interactive and have you guys ask questions, or if you want to talk about something which is not on the slides. I've tried to talk about database as a service in general, and specifically Trove, which is database as a service for OpenStack. I'm perfectly happy to broaden it to OpenStack in general, anything else which you might be interested in. So let's keep it interactive and stop me at any point in time. I gave you a rough idea of how much stuff I have, so even if you're going to take me a little bit afield, it's fine. So what are we going to talk about? Like I said, at a high level, what is database as a service? There used to be a time when if you had a conference and you didn't have at least 6 sessions on big data, you got fined. Now, if you don't have at least a couple of sessions with something as a service, I understand you get fined, so I'm one of them. We'll talk about OpenStack and Trove. We'll talk about Tesora, and we'll talk about, I expect the first couple of these things will be, does this work? Yeah, it works. First couple of these will be relatively short. I expect to spend most of my time on the slide which talks about architecture, and we can dig into the architecture as much as you want. And I'm going to be here for a little bit after the talk, but not a whole lot longer. My contact info is on one of the slides, so if you need to get in touch with me, you know how to do that. So a couple of quick warm-up questions. How many of you have used OpenStack? Show of hands. Good, okay. How many of you have used Trove specifically? Okay, good. Sorry, what was that? We have it installed. That's way better than a lot of people. Great. There are a lot of potholes in getting it installed. So good thing you got it installed. Okay. What databases do you use in your company? Shout them out. What names? Postgres. Okay. Oracle, MySQL. Anything else? SQL Server. Sorry. SAS. Okay. Others? Sorry, I heard 2 answers up there. MariaDB, okay. No SQL databases in this crowd? Mongo? HBase? Cassandra? Anybody? Redis? Cassandra, Redis. Okay, so they're all databases, by the way. We're a very inclusive community in the database community. They're all databases. Also, how many of you used cloud services from Amazon? I picked Amazon, but any other cloud services? HP Helion Cloud, Rackspace Cloud? Anybody here from Rackspace in case I disparage them later? I saw them downstairs. Nobody from HP here, right? HP? Okay. Specifically, how many of you have used RDS? Okay, good. All right, so I have a rough sense of where you guys are at. Let me tell you a little bit about me and get on with this stuff. I think a presentation is supposed to be fun for both you, informative, fun, but it also has to be fun for me. So once in a while I try to do something wacky like this. Anybody who can read the bottom line there? No? Who? There was. Okay, so fun. We've got somebody pretty close to the bottom. All right. All right, so who am I? So I work for a company called Tesora. I started the company about 6 years ago. We're the database as a service company. We're the company behind the Trove project. And Trove is the OpenStack database as a service project. And a couple of years ago, when we had a bunch of people who were trying to use Trove, like this gentleman here who tried to install it and have a lot of trouble, we ended up writing a book on Trove. So I'm one of the authors, along with Doug Shelley, one of my colleagues. I'm doing a giveaway of the books. So some number of you, depending on how many are in the room, I'll email you an electronic code so you can download the book. So I've requested Simon to pass out a sheet of paper and get your name, your email address, and what company you work for. And we'll pick at random some number of people. Typically, we've done 10%. And mail you an electronic coupon to download a copy of the book from Apress. So he's handed out a sheet of paper for that. All right, so with that done, so I have two pictures which kind of illustrate a problem with databases in a contemporary IT organization today. There was a time not too long ago when if you were a developer and you went to your IT organization and you said you would like a database, they would probably say you can have any database you want as long as it is, and they'd fill in one name there. You can have any database you want as long as it is MySQL or Oracle or something like that. There was a notion of a corporate standard. When you requested a database, it typically took a while to get one. 3 years ago, 3 years ago, I was down in Atlanta talking to one of our prospects, and they were telling me that in order for a developer or a QA person to get a new database instance, sometimes took 3 or 5 months, which is just, I think, crazy. So there's a whole sense of things which, from the developer's perspective, you look at and say, this just doesn't make sense to me. So there was the time when all applications used one database, the corporate standard database. But today you have applications which use multiple databases. Use a SQL database for something and a NoSQL database for something else. IT never seemed to understand what that concept was. Now you look at it from the other side of the table, and the IT guy says, why don't you just use one corporate standard database? There's this fundamental disconnect. The things which IT is being asked to do, keep my data safe. Make sure the data is, not used in some way which compromises people's private information. Make sure that you have backups. Make sure the configurations are right. On the other hand, the developer wants to use the new technologies which are making applications better to use. They're being tasked with be agile, use new frameworks which require new databases. So there's this fundamental conflict, and this ended up causing things like shadow IT. How many of you have had this problem in your workplace? Yeah. And eventually people figured out that there is really an issue here. Multiple databases for a single application is a reality. You got to deal with it. On the other hand, you can't expect IT to be experts at every single database out there. Yet IT is being tasked with providing within the IT organization to the internal customers multiple databases. So how do you solve that challenge? And one of the solutions, thanks to Amazon for showing the way with this, is and I particularly like the Coke machine motif here for a reason. It's self-service provisioning. You need to be able to get a database just as easily as you can get a can of Coke out of the machine. Stick a couple coins in, get your database. When it doesn't work, you shake the machine. That's different. We won't talk about that part of it because that never happens. But the basic idea is you need self-service provisioning. The database needs to be managed for its entire life cycle. It's not just self-service provisioning. Puppet, Ansible, Chef, they can do self-service provisioning easily. What do you do once you have the database? That's really important as well. And it's not just one database. It's many databases. It may be an application which uses MySQL, another application which uses Postgres and Redis, a third one which uses Oracle and something else. Those are real problems. How do you deal with that? Now, there's a couple of different ways in which you can do database as a service. We'll talk about it for a second. So I'm going to put a little flag on this thing which says leverages the native capabilities of databases. We'll talk about it in a second. But this is something which cannot only be in the public cloud. Amazon's databases are great. Amazon RDS is wonderful, but it's in Amazon's cloud. It's not in your cloud. How do you do all this in your own private cloud? How do you do this if you've already got a cloud service provider who's doing a managed cloud for you? So these are some of the problems which, at a higher level, OpenStack set out to address, and specifically Trove, the database as a service project for OpenStack, set out to address. So the Trove mission is very simple: to provide a platform and a framework for managing relational and non-relational databases. Okay, very important, it's both. So let's go back to the Amazon analogy. I asked how many of you used RDS. Yeah, some of you used RDS. How many of you used DynamoDB? How many of you used Redshift? Okay. Roll all of them together. Private cloud, you have Trove. Okay? So Trove is relational databases, NoSQL databases. We even have a couple of data warehousing databases running currently. We'll talk about which ones they are. But it's a framework in which you can orchestrate a collection of databases. Okay? That's the mission statement. Let's actually look at, in detail, what it means. First, provisioning. I want a database. I want to go to a website and click, give me a database. I need to get one. Provisioning, very important. I say go to a website. Yes, there's also a RESTful API. There's a CLI. It's all the same thing. You, as an end user, should be able to execute one command and get a database of any kind you want that is supported by your cloud operator. Provisioning. Okay. Now, typically, databases are not single instance things. How many of you would go into production with a single instance of MySQL? Geez, I don't see anybody. Can you guys hear me? You would. That was a single instance. You said Oracle earlier. That's why. Yeah. Okay. I said production. But so databases have these complicated topologies. Some have replication, some have clustering. And you really want to make sure that you get those things right if you're running your application in production. And replication and clustering are not just for high availability. In some cases, it's also for performance. If you have a single instance of a database, maybe it's not going to be good enough for you. Maybe you need to have multiple instances of the database and spread the load across them. Need to support that as well. Okay. Now, we're done with provisioning. Okay, so I asked for a Mongo cluster, and I got myself this 7 replica set, 6 shard configuration, and it's got n query routers and some number of configure servers. I have the whole thing. It's up and running. Now what? I have a whole bunch of data in it. What about the rest of the lifetime of this database? What do you do about backup? I took a backup some months ago. I'd like to launch a new cluster from that. How do you do restore? I want to fail over one of the instances. The hypervisor is not running OK. I need to take that instance out for service. I need to do failover. Or I have a situation where I say, yes, did I say 6-member replica set, 7 shards? I don't know, pick a number. I want to add some more. I want to grow the cluster. I want to shrink the cluster. These are all operations which you typically do with a database topology. How do you do all of those things in an automated manner? Of course, I said multiple databases, but also I would like one API to do all that with. If I want to request a MySQL version 5.6 instance and a Postgres version something instance and an Enterprise DB something else instance, I want the same API call. I want to take a backup of a database I already have running. No matter what the database, I want the same API call. Common API call for all databases. That's something which Trove supports. Currently, Trove mostly does this for free and open source databases. We have some extensions to do non-free and open source databases. We'll talk about that. And once you have a RESTful API which can do all of this, yeah, you can build a web interface. You can build a CLI on top of it. Trove has those things as well. So what is Trove? It's a heck of a lot more than provisioning. It's complete lifecycle management for databases, multiple types of databases, all with a common set of APIs, all with a common interface. And oh, by the way, there's CLIs and web and so on top of that as well. Okay? I'm going to stop here and say, does that make sense? Does anybody have a question like, why the hell would you do something like this? That's a leading question. Somebody better have that question. No?
Why the hell would you do something?
Thank you. Somebody is there. Okay. So imagine you're I was scared, so nobody's going to say that. So then I don't know what to do for the next slide. I don't know how to get the segue over there. How would you, if you were running an IT organization and you had thousands of database instances and you wanted to automate your operations behind this? As an IT organization, if you wanted to operate a self-service portal for your internal customers to request a database, and I'll give you the list of databases which people want to use in a company. MySQL. And oh, by the way, when I say MySQL, I mean MySQL Enterprise, I mean Percona, I mean MariaDB, and maybe there's 3 others I don't know yet. I want Postgres, and I also want Crunchy SQL, I believe it's called. And I also want Enterprise DB, and I also want Splendid Data, which are all, by the way, Postgres variants. I want Mongo Enterprise, I want Cassandra, I want DataStax, I want Couchbase. Okay, you see the words, I want Vertica as well. And DB2, there's somebody who wants DB2 and somebody who wants Oracle. Simon wants Oracle. And you have to manage this entire set of databases on your internal self-service portal where you're going to go in there and say, I want a database. Imagine the mess that's going to be if each one of those had a different API set. Imagine if you were implementing the take a backup of your databases button, and each one of those had a different API set. The right place to abstract it is in the service. That's what Trove does for you. Other questions? Okay. I made a mention earlier about give you the native capabilities of the database, which is a kind of important thing. I asked DynamoDB, and one person raised their hand in the room. But DynamoDB is Amazon's NoSQL managed database service. Fundamentally different from RDS in that DynamoDB is the query API is something which Amazon intercepts before it sends to the actual database. It's a multi-tenant API, but the application never talks directly to the database. It talks indirectly through Amazon. In Trove, the fundamental paradigm is this. If this is your database, here, your database server, your MySQL, your Postgres, what have you, you can interact with it at 2 levels. One is a data plane and one is a management plane. At the data plane, you have applications. They have SQL connections to the database. They insert data. They read data. They modify stuff. You have some set of things like queries and so on going on there. A very different set of things happen at the management plane. You have provisioning, you have backup and restore, you have clustering, topologies, replication, all that nonsense. OpenStack very, very consciously Trove sticks very consciously to the management plane. Trove is not in the business of getting into your data. Your application will connect directly to the database. Trove is entirely oblivious to that. Very important concept to remember. Trove does not intercept your data in any way. If your application is a MySQL application, it will talk libmy on port 3306 to the database, or whatever port you happen to configure. If your application is an Oracle application, it will talk standard SQL+ to the database. Trove does not get in the way of that. Not the same as DynamoDB. Okay? That concept clear to everybody? All right. I quickly mentioned a list of databases. So here's the actual complete list as of this point in time. MySQL, including Percona and MariaDB. ExtraDB cluster for the clustering with MySQL. Postgres. There's very nascent support for Enterprise DB at this point. It's not even released. There's support for Vertica for those of you who have a need for a scale-out database. IBM contributed DB2 Express. We contributed Oracle. And on the NoSQL side, there's Mongo, Cassandra, Couch, and so on. And we're working on Mongo Enterprise and DataStax at this point in time. So if you use any of these databases, and I know that there's a couple of databases which were mentioned which are not on this list, SQL Server and SAS to be specific, If you use any of these databases, Trove will be able to help you. Okay? All right. Changing gears a little bit. Since most of you here did not use OpenStack, some of you did use OpenStack, before I go any further, I have to talk a little bit about what OpenStack is. OpenStack is a collection of services which allow you to orchestrate your entire private cloud. So there's a service which does compute. It's called Nova. There's a service which does networking. It's called Neutron. Or there's another one called Nova Networking as well. There's at least a couple of services which do storage, Swift and Cinder. But each and every one of these services in OpenStack follows this exact same template. And I'll talk about this template for a bit. So this box here, the hard line box, shows everything which is part of this service. There's an API for the service. It provides a REST API endpoint. In order to implement whatever the service functionality is, there's some number of other component services which are required. I've shown you 3. And all of these component services in the API interact over a message bus. That's typically RabbitMQ. It's something which looks like RabbitMQ. And the service itself has some persistent state. It stores that in a database. That's typically MySQL. It could be SQLite. It could be anything which is SQL Alchemy supported. That's the structure of a generic OpenStack service. You look at Nova, it's going to look like this. You look at Cinder, it's going to look like this. You just have changed the little names in the boxes. And then there's this little dotted line around the service here. And that dotted line basically says if you have 3 of these services, nothing from outside the dotted line can get into the dotted line. If Nova wants to make a request of Cinder, it will talk to the REST endpoint, and only to the REST endpoint. One service will never go stick something in another service's message bus. One service will never go write something into the database of another service. This concept generally clear? The way in which you would implement a distributed scalable service architecture? Anybody got questions about this while I get a sip of water? Yes?
Are there other message buses other than Rabbit?
Hang on for a second. So OpenStack provides an abstraction for the message bus called Oslo Messaging. Oslo Messaging has drivers currently for RabbitMQ and Cupid, I believe. I don't know of others. There may be others that I don't know of. Most people use RabbitMQ by a wide margin. I've seen people use RabbitMQ or Cupid. I'm not sure of others. Other questions? Anyone? Nope? Okay. Okay, so now that we know what a generic OpenStack service looks like, that's what Trove looks like. So this is the slide I said I'm going to sit on for a while. So we'll sit on this for a while. So let's start with these services here in the middle. These are the common core services of OpenStack. If everybody is familiar with those, I'll just skip right over them. But if you want me to go into them in detail, I will. Okay. Let's start at the top. Swift. Swift is the object store service. Those of you who used Amazon, it's like S3. Cinder is the block store service. Elastic Block Store in Amazon, EBS, that's Cinder. Nova is the compute service. EC2 in Amazon, that's Nova here. Keystone is the identity and access management service, and also the service catalog. It is loosely related to IAM in Amazon, but Keystone does a lot more than IAM does. Neutron is the networking service. There's 2 networking services in OpenStack. One is called Neutron, one is called Nova Networking. And Glance is the image service. In Amazon, for example, you store AMIs. AMIs are stored in some repository somewhere. OpenStack has a specific service called Glance, which is all of your images. If you need to boot a virtual machine, you need an image. Store your images in Glance. Okay? So if you wanted to deploy Trove, the first thing which you need to do is you need to get all of these component services up and running. Anybody here want to know what happens if you don't run Swift? That's a pretty common thing. People don't want to run Swift. If you don't run Swift, there are specific pieces of Trove functionality which will not work. Specifically, backup and restore is currently hardwired to go to Swift. Replication uses backup and restore as the default way in which to create a replica. You have a MySQL instance, you want to replicate it, you want to get a second MySQL instance. The way in which we do it is we take a backup, and then we load the backup, and then we go from there. Well, if you don't have Swift, you got no backups, you got no replication. Okay. Swift is not optional. Some of you want to use Ceph. There are some known issues with Ceph at this point in time. We're working on fixing them. Specifically, Swift URLs don't support tenant IDs. There's a bug which has been open for a long time. If that's a particular problem for you with Ceph, let me know. We can, add your pain to that bug report. Okay, so you got all of the component services there. And on the right here, you've got Trove, and we'll get to Trove in a second. But let's start here at the bottom with this thing called a guest image. In order to use Nova, you need to have a guest image. Guest image is like an AMI. If you want to boot a virtual machine in Amazon, you need to have an AMI to boot it from. If you want to boot a Nova instance in OpenStack, you need a guest image. So Trove has guest images. And a Trove guest image is a little bit more than a Nova guest image. It's got an operating system, some operating system. It's got some database which you chose, say MySQL or Postgres or what have you. And it's got this little thing called a Trove guest agent. So we're going to talk about the Trove guest agent in a bit. So remember, that's the thing which differentiates a Trove guest image from a Nova guest image. Nova guest images don't have guest agents. Trove guest images do. Okay. So like this gentleman here, you got Trove all up and ready and installed, and that's this stuff over here. And Trove itself has 3 services. The API service exposes a REST endpoint. It's got a message queue. Oslo messaging wraps RabbitMQ or something like that. Some persistent store, a little MySQL database where it stores its own stuff. A service called a task manager, and a service called a conductor. These 3 are the services which run on your Trove controller side. They could run on the same machine where you run the rest of your OpenStack, but I would strongly recommend you have a separate message bus for Trove and keep it separate from your infrastructure message bus. Matter of best practice. We can talk more about why later. So you did a little bit of magic. You got Trove up and ready. And now you're at the point where you can say, Trove create. The first call you're going to ever do on Trove is probably Trove create. Trove, create me a MySQL instance version 5.6. Comes in there. The API says, OK, who are you? Who are you to ask me to do a Trove create? Do you have any credentials? Sure, here's my token. And you'd have got a token from Keystone saying you are, user John, password something or the other. You hand it to Trove, and Trove goes to Keystone and says, is this really John? Is this token valid? And Keystone says, hopefully, yes. In which case Trove says, sure. Do you have the quota to start this MySQL instance you want? How many instances are you allowed? You're allowed 12 instances? Great. You want 1? You're in good shape. OK. 202, come back later. Here's an ID for your instance. We'll talk in a bit. And it sends a message over to the task manager, which does all the heavy lifting. So Trove API, front-end interface, it's basically a Whiskey server. Task manager, heavy lifting for Trove. So message comes over the bus. Task manager picks it up and says, OK, John Smith wants to have a new Trove instance, MySQL 5.6. OK, little database here. Do you know what MySQL 5.6 is? Yes, cool, OK. Do you have an image for that? Yeah, it's over there. How big did John say he wanted his database to be? Oh, he wanted 100 gigabytes. Good. Cinder, Nova, could you give me a Nova instance with 100 gigabytes of storage attached to it? And would you boot this image on that for me, please? So Trove just passes the request to Nova and waits. And a minute later, Nova comes back and says, here's your guest instance. It's up and running. And oh, by the way, you wanted to have a network on it. The network address is 10.0.0.2. So that's that machine up there. So the guest image at the bottom left became the Nova instance up here. And now you have an operating system, whatever, Ubuntu, Red Hat, MySQL version 5.6, which you requested, 100 gig of storage attached on Cinder, and the MySQL 5.6 guest agent. We're up and running. And the first thing the MySQL guest agent does is it connects back to the message bus. And when it shows up there, the task manager would have given it a message saying, prepare yourself as a MySQL 5.6 guest agent. So it goes, does a bunch of things there. It launches the MySQL software. It mounts the correct storage, initializes the database, whatever it needs to do. And then the application can connect to it directly. Now, that entire black thing up there, the application and the database software, notice Trove is nowhere in that picture. Trove doesn't get in the middle of this. This is port 3306, open on the public interface. The application talks to it. It's done. Trove just orchestrated the creation of this thing. OK? I'm going to stop. And there's a couple of curious, yes?
From a performance standpoint of the operating system, the tuning that you might do for your database and such, does that go into the image, or how does that stuff?
Excellent question. So the question was, there are some operating system tuning parameters which need to go into running that instance correctly. Where do those go? Do they go in the image? Do they go somewhere else? OK. The answer is, it could go either in the image, or it can go into something called a configuration group. Now, we talked about Trove being more than provisioning. One of the features it provides you is a thing called configuration groups. When you build this guest image, are we out of time already or something?
No, they've finished it.
OK. So when you create this instance, when you create this image, you configure it and specify a list of configuration parameters which Trove will allow you to manipulate through Trove. So you could come in here and attach a configuration set to it and tune memory use, query cache size, whatever you want. And Trove will make sure that that database running there has those parameters. If it's MySQL, it'll be in my.cnf before that server is launched.
What about that, something like the kernel tuning parameters?
The kernel tuning parameters are typically going to be baked into the image. Okay? There is, at this point, no way in which Trove can tune any of the kernel tuning parameters. If there is anything, it's in Nova, but Trove will control how you access that instance, so you won't be able to do that. So you have to bake it into the image. Okay? So now you have a machine up and running. And now the question, of course, is, why the hell do you need to have that guest agent up there? And the answer is relatively simple. There's a common API on this side. No matter whether this is MySQL or Postgres or Oracle or what have you, the API to create, the API to backup is the same thing. But the exact way in which you do a backup on MySQL is different from the way in which you do a backup on Postgres. So you provide whatever API you want here. The guest agent translates it to the native database. So the guest agent is effectively the translator from some Trove common semantics to per database semantics. And these guest images are not provided by Trove normally. Trove provides you the framework, all of this stuff. It provides you with a guest agent as a reference implementation for most databases. It doesn't provide you with guest images. So you can make your own guest images, standard disk image builder style guest images. If you use VMware as your hypervisor, it's a VMX. But those guest images are things which Trove is going to require in order to boot. OK? Go ahead.
So as far as like the differences in backups and stuff, is that something I can take that MySQL dump and walk the operation?
Excellent.
Snapshot or
So there's two ways in which you can do a backup. One is you can come in on the application side and do a backup directly. You can do whatever you want on that interface. The other is you can come to Trove and say Trove backup. And Trove implements a set of strategies for operations. So for backup with MySQL, there's three strategies. There's MySQL dump, there's Percona XtraDB full backup, and XtraDB incremental backup. So you could come in here and say, Trove backup create, instance ID, and whatever the configured strategy is, it will attempt to use that. Typically, people configure incremental to be the configured strategy. If you don't specify a parent, it will do a Percona ExtraDB full dump. If you specify a parent, it will do an incremental from that parent. So that's all baked into Trove. So the value of that is this. Whether it's Postgres or MySQL or what have you, or Mongo, Trove backup create will translate it to the right thing here. And somebody who's got good knowledge of that particular database would have implemented the strategy for that database. So that's how you get the benefit of it. Other questions? Yes?
Are there any different ways in which you would handle upgrading MySQL, between point releases, or updating, for kind of toolkits?
So currently updates so there's a whole bunch of conversation about how to do updates. There's the update of the database software, there's the update of the operating system, there's implementing patches for that. All of that we're expecting to have in the Mitaka release, which is the next release in 5 months from now. Currently, upgrades are it's a manhole without a cover. Somebody here had a hand up.
I just had a question about updates.
Okay, so hopefully in 5 months we'll have an answer to it. Right now, what a lot of people are doing is they're orchestrating the updates using some salt mechanism on the back end. It's currently not supported by Trove, but that's going to change shortly. Other questions? Yes, sir.
With the application connecting directly to the database, does that mean that Trove's kind of removed from the high availability factor of things? Like, is there a bit, or how would failing to work if your application?
Excellent. So when I say the application is connecting directly to the database, I'm glossing over the load balancer and anything which might be there. You can perfectly well launch, okay, so I launched the first database instance. Let's assume this is MySQL. Then I can say Trove create replica of that thing. Instance count 4. Now I'm going to get 4 instances which are replicas of this. Now I got 5 of them. So all of them have a connection endpoint. You can put whatever load balancer you want in front of it and point it at these 5. When I say application, I don't necessarily mean it's your end user application. That might be your load balancer. When a failure happens, it's up to the load balancer to determine, oh, that one failed, so I'm going to take it out. If it's a run-robin DNS, it's going to take it out of it. Trove itself doesn't provide a DNS. Trove itself doesn't provide the load balancer. Okay.
MySQL has its own set of permissions, that kind of thing.
Perfect, yes.
Does Trove have any mechanism for providing, here's my application set, here's my local set of
Yes.
permissions, or do you have to do it separately?
So you can do it in one of 2 ways. That's a MySQL database. You can go in on the MySQL connection and do it on port, on MySQL. You can also do Trove user create, Trove database create with granting of permissions. So there is a subset of what is supported by MySQL on the Trove API. The good thing with that is if you have your own management interface which you want to create for database as a service self-provisioning, that interface could be as simple as, what database would you like? Pull down list, MySQL 5.6, cool. What users would you like to create? What databases would you like to create? And your UI could directly orchestrate that with a bunch of Trove API calls, all packaged up as the create request. That goes down to the instance right when it's created. When I told you that the first thing the guest agent does is it connects here and it picks up a prepare message. In the prepare message is all this stuff which you said, create these databases, create these users, here's their passwords, here's the permissions, all that nonsense. One message. So when you get to connect on the front end, all those things are set up for you.
Does the Trove guest agent also somehow help with MySQL crashing or error logs and stuff? Or do I just need to get the machine identifiers and move into the machines myself?
Okay, great question. Does Trove allow you to get to guest agent logs and so on? As a matter of deploying Trove in production, allowing SSH access to these instances is a bad idea. Currently, the only way to get access to the error logs is through SSH. Actually, yesterday, the blueprint for data store log retrieval was pushed upstream. The code is going to go upstream as well. And I'm going to move to the next slide and tell you that all of this stuff which you're talking about with data store log retrieval hasn't been in our version of Trove for, I think, 6 months now. So great segue, 5 minutes to go. who paid for my plane ticket to come here? This company I started. We're the company behind Trove. We do not offer a service. We're not competing with Amazon, though we'd crush them. I know that. No, we're not offering a service. We give you the software. You can run it in your private cloud. Okay? It's based on OpenStack Trove, but it's a little bit ahead of what Trove typically has. Obligatory Piechart. We're one of the largest contributors to the Trove project. This is Kilo and Liberty, the last two releases. Gives you a sense for, first of all, it's a diverse community of people. You got Oz, you got HP, Red Hat, IBM, Mirantis, major contributor to OpenStack, eBay, and so on. But we're definitely, at this point, one of the leading contributors to the project. And what we have is a product based on Trove. Trove is a framework. Doesn't give you guest images, doesn't give you a lot of things. We give you all of those things, plus we give you early access to a bunch of features like log retrieval. We have people who are running our software in production, and they're already able to do those things. So you guys can see what it says. So since we have 5 minutes to go, I want to point out, if you have additional questions on IRC, OpenStack Trove, OpenStack IRC on Freenode, info@tesora.com will get you whatever you want. And if you have other questions, feel free to email me, IRC me, whatever you want. We have a blog which regularly has stuff about Trove as well if you're interested, so sign up for that. And I'll leave that slide up in case anybody wants to copy it, but let me make sure everybody signed up on that little sheet of paper which was running around. Anybody not sign up? You didn't sign up? No. Okay. You had a question? No. Okay. Other questions?
Why isn't there a library of public Trove guest images?
Why isn't there a library of public Trove guest images? There is a plan to do that, similar to the Sahara guest images. The folks from Red Hat want to do it. The reason why Trove never ever wanted to go that path is because if you say there's a public repository of images, there's an implicit assumption that, one, OpenStack has the ability to distribute those databases. Sorry, we don't. And OpenStack Trove is going to support you when you have a problem with that guest image. That's the reason why the community never went that route. Okay, we're part of the community, but we're a company. We're happy to provide you with guest images, support the whole 9 yards. That's the reason why there isn't one in the community. You had a question up there, sir.
Related question. How do you handle security patches and things like that if you're running a database at the time?
Similar to the question the other gentleman asked, right now security updates is something which is not supported by Trove. Mitaka release will have security updates. The mechanism is going to be very simple. There's going to be a single point on your management network where you can say, here's a patch which I, as the operator, would like to apply to all the fill your data store, MySQL version 5.6 images. And then you can go and deploy those. There's the issue of, does the end user of the database get to decide when the downtime is going to be? Do you do it unilaterally? Those are operational issues. Trove is going to stay out of that. But there's going to be an API call which says, Trove apply patch potentially. Point to an instance, point to a patch, and say, patch meet instance, instance meet patch. You guys figure it out. So that will be in the next release. Other questions?
Another one. How hard is it to add a new database? Let's say I invent a database that's not out there already in the world. What does it take for me to write the plugin such that it will fit in?
So I've done both of those things. I can tell you inventing the database is harder than adding it. No, it's...
Imagine I've done that.
Assume you've already done it. So we've all done that. We've all created a database or two. So there's different levels of support you could get for a database. So you want bare minimum support, provision a single instance, do the ability to resize the instance. Nova takes care of most of that for you. And that's about it. Call it 2 weeks. You want to implement backup and restore. You want to implement clustering. You want to do something more. It depends on how perverse your database itself is. Call it another month, month and a half. Then you get into the process of how long does it take for you to actually get that code consistent with the rest of the project, call that a month. So we've added support for Oracle. That's about the order of time it took. Thank you. Thank you all.